and Banashri Thapa at CW from the Sustainable Food Systems team to take the conversation forward.
Thanks, Kunalika. Good afternoon, everyone. At the Council, climate resilience is an important and a critical area of work for us. One of the, in fact, the biggest teams at the Council works in climate resilience. We did a CVI Climate Vulnerability Index in 2021, which is one of the most Googled and quoted report. 2023, we did sub-district level monsoon pattern across India and subsequently heat index in 2024. We are in the process of working with 300 cities to create 300 action plans and host the South Asia hub for the Global Heat Network. Doing all this, so much of climate data and working with so many governments at the state and national level, we realized there is a climate data is large, isolated, complicated, and it comes from multiple sources. Data alone is not the answer. It needs to be intersected with sectoral data layers to really draw the insights. And again, we have a lot of risk models lying in a lot of GitHub repos, research papers, but they are not available at the point of decision. That's where we imagined a single platform that can modular, scalar, integrate with multiple data sets, and with the ease of visualization, downloading, comparison, etc. Climate data comparisons across horizons, process data across metrics like precipitation, heat, temperature, sectoral data sets around, example, infrastructure layers like data centers, power, agriculture, all come together to draw risk profiles for districts. And all of this come together in an API format, friendly format, which is interoperable, works with multiple systems coming together and working together. What you see on the screen is a short demo video of the product that are going to soon to be launched. And we didn't stop there. We extended it to become a conversational climate agent, which works with authorized public data sets. You can find queries in natural language, extracts information, and those queries can be complex, relate multiple data sets together, and you can get answers in forms of tables, charts. Okay, you can see that on the screen. So I was talking to these charts, tables, etc. can be downloaded and utilized in reports, presentations, etc. Moving on. Second use case that we explore with AI and climate resilience is geospatial AI, where we go from risk, district level risk or sub-district national level to exactly building level risk. That's where we use geospatial AI to have neighborhood level risk zones. And that's where actual decisions of adaptation infrastructure or highlighting risk zones actually take place. At the end of the session, the people who are attending session, we would be displaying a QR codes and would be giving access for a preview of the product and early beta user. I hand over to Banashri to speak on the work for AI for agriculture now. Thank you.
Thanks, Weber. He mentioned that climate data is complex. Well, for agriculture sector, which is dominated by small and marginal landholders, agriculture data is just as difficult to, just a second, to track, monitor, report, and analyze at the farm level. Over decades, decision makers have relied on coarse and aggregate district level data derived from agricultural census, national surveys, and crop cutting experiments to analyze and understand farm level insights. But imagine if you could get insights on agricultural fields at the farm level, at the plot level, in real time, and during each season. Innovations in field level visualization via Google's Anthrokishi tools, Amnex and other players in India are transforming the way in which we learn about agricultural decision making in real time today. But why are these transitions important for India's food systems? India's crop systems rely heavily on monoculture and three dominant crops. Rice, wheat, sugarcane consume over 45% of the total gross cropped area. Overly absorb and consume India's annual fertilizer subsidy bill, and rice buffer stocks are actually 3 times more than the required amount, leading to a wasteful use of resources. Crop diversification offers a climate resilient and a growth-aligned strategy for agriculture sector, yet scales to fail because of challenges in policy delivery and implementation mechanisms. We reviewed state-level policies of diversification across India, and we highlighted the bottlenecks that hinder crop diversification incentives through direct benefit transfers to scale across farmers across states in Haryana, Punjab, and Orissa. We find 2 key bottlenecks. First is that incentive amounts are insufficient to truly motivate farmers to diversify away from rice. And while that is a problem for economists and maybe taken up in a different session, the challenge that we are trying to highlight here is the lack of trust, not just with the farmers, but also with policymakers. At the farmers level, the challenge remains around delayed payments for actual farmers who are transitioning away from rice, but also poor grievance redressal when amounts don't come to their payments or their bank accounts, or they are left out of the schemes. For policymakers, imposter beneficiaries and fraudulent claims of crop shifts without actually shifting derails and demotivates them to pursue direct incentivization for crop diversification. AI-powered tools can unlock these underlying pain points for diversification and allow scaling of diversification across India. Due to the paucity of time, I will highlight only 2 use cases of such use cases that are now being enabled through AI-powered technologies. With Google's AMED agricultural tool, as well as Amnex, they are now able to identify crop growth at different stages in agricultural fields, allowing payments to directly, automatically get transferred to farmers during the cropping cycle without delays in payments and without verification delays at the ground level. For policymakers, land use classification tools enabled by Google's ALU supports classification of land types as agricultural land, urban land, or other lands, allowing for identification of correct beneficiaries and allow targeting of schemes. Together, what we realize is that these tools can enable crop diversification policies which require behavioral change at the farm level and motivations at the farm level to be targeted and allow for governments to use these insights to ensure that crop diversification schemes are targeted and scaled in a staged and smart manner. This was a use case that we wanted to highlight in agriculture in a sector which is fragmented and deals with data gaps, and hopefully this will kind of enrich the discussion that our panelists will later have. With that, I hand over to Kunalika.
Thank you, everyone, and welcome to our session again. We'll be having a wonderful panel discussion moderated by Dr. Arunabha Ghosh, the CEO of the Council on Energy, Environment and Water. I will hand over to him to introduce the panelists and lead us into the conversation.
Thank you, Kunalika, and thank you, Vaibhav and Banashri, for the presentation. Good afternoon, everyone. Welcome to this session hosted by Google and CEW. We front-loaded the report launch so you can understand why we wanted to focus a lot more on how do you deploy AI for resilience, whether it's in agriculture or generally. AI and climate science are, of course, advancing at an unprecedented pace. But at the same time, we find that despite these technological advances, the intelligence still fails to reach the decision makers or to the market enablers or to the market participants in a way that delivers effective action at scale, especially in the global south. This is why we've worked on this paper on AI in agriculture, but as Vaibhav also demonstrated, the tool that we are developing and which will be launched publicly as a digital public good offering from CEW as a climate resilience atlas, we're looking across agriculture, water, urban systems, etc., to make sure that the insights are usable, trusted, and embedded within real planning and response systems. So in this session, we explore how AI-enabled climate intelligence can move from models to the masses, supporting preparedness and planning at a hyperlocal level, whether it is a village, a neighborhood, a city, a district, or beyond. By examining these real-world deployments, as well as the governance needed for this, we hope to highlight how science, data, policy, markets, and action can come together to fill the last mile gap and deliver climate resilience where it matters the most. We've got a terrific panel. We're just going to quickly introduce them, and I'm going to dive straight into the questions and let them do the hard work. Professor Manbendra Saharia. Professor Saharia leads the HydroSense Lab at IIT Delhi and brings deep expertise in climate extremes, flood risk, and translating geospatial science into decision-relevant frameworks. We also have Ms. Ashley Thomas, who leads climate and environment portfolios at Google DeepMind Impact Accelerator, working to translate frontier AI research into real-world climate action, similar to what you just heard. Got Dr. Ramprasad Manohar, Chairman of the Bangalore Water Supply and Sewerage Board, bringing the perspective of frontline governance at an urban level, dealing with growing climate stress. And we have Ms. Kay McGowan, who's Senior Director for Policy at the Digital Impact Alliance, bringing in a global lens on governance, equity, and digital public infrastructure for public good, in particular climate data. So let me dive straight in. Professor Saharia, from your experience and from what you also saw, which are the areas in terms of real-world impact where you think climate models and AI-driven research can move from pilots to proofs of concept and beyond? And in that vein, could you also tell us a little bit about what you do with HydroSense?
Sure. Thank you, and welcome everyone to the session. Everyone is very serious right in the morning, so I think we can take a few seconds to just smile. Climate is such a wide field. It's very difficult to make an assessment where and which models are getting the highest play in terms of its impact on governance, its impact on policy, on implementation on the ground. But I can pick one or two areas where I work or maybe I don't work that much in certain areas, but where I think there is the highest possibility of impact, and we are also already starting to see how the models are getting utilized. And I think the two areas that I would like to highlight is disaster management and impact assessment. Now, in terms of disaster management, it's more like a vertical than an area, and everything under the sun kind of falls in disaster management, starting from flood risk, landslide risk, storm surge, coastal risk. All kinds of risks fall into this domain, and you will see in the past 3 to 4 years, there has been almost there has been a deluge of AI models in this area coming out of labs from across the country as well as across the world, and of course from companies around the world. We have Google with us in the panel, so they will talk about their models, but you will see a lot of, which didn't used to happen. Till 5 years back, companies never really paid much interest to this kind of modeling. It was always the forte of research labs. But now more and more you are seeing these models because the companies are seeing obviously some financial value to these models, but at the same time, its impact on people is so large. Like being able to develop and deploy a national landslide model, for example, not only makes our infrastructure more sustainable, but it also, there is a lot of research that actually goes into the model, so it allows us to kind of connect our students to and researchers to cutting edge work that is happening. So I think disaster management is one area where AI models have made a large impact, and we will start seeing its integration with government systems from now on. And the second part is impact assessment. So I think this is a very important area. So traditionally, people have always stopped at hazards. Most of the modeling efforts have always concentrating on forecasting and hazard. How can we forecast? Can we forecast 2 days in advance, 5 days in advance? But oftentimes, what we are interested in knowing is, if we are able to forecast it well, can we actually forecast how many buildings will get damaged? Or is there any risk to a dam or a reservoir or a bridge that is downstream? Is there any risk to that area? So what we are more interested in is actually impact assessment. But now with the kind of geospatial tools that are coming in, it's possible to do large-scale risk assessments. Earlier, risk assessments would always be site-specific. Now, I'm a civil engineer by training, so my field is entirely site-specific. But now, we are also making a transition to more being a site-specific field to a large-scale field, because it is now possible to do risk assessments at scale. So I think these are two areas that I see large impacts of AI being already in place, and more we'll see it being integrated with government systems.
Thank you. We'll talk about both of those as we proceed along the panel. But since you talked about both disaster management, but also impact assessment in advance, maybe I'll turn to you, Kay. Across the world, digital public infrastructure has scaled significantly. India made it a point to highlight the potential during its G20 presidency, but we haven't seen it scale enough when it comes to climate action, climate resilience. So could you reflect a little bit on how we can integrate AI onto a DPI stack and bolster the climate resilience aspect, which has perhaps been a little less explored and impacted so far?
Yes, sure. Is this on? Yeah. Okay,
yes.
So first of all, I just want to thank the Council and Google for inviting me. This is very exciting. I was discussing with a colleague earlier that we usually worry about, if there are going to be too many empty chairs when we talk about our work. So this is really exciting.
Kay, could I request you to hold it a little closer to your...
Sure.
Yes.
Is that better?
Yeah.
Okay.
The din outside is...
Yeah, of course.
trying to drown us.
Yeah, no.
We have to be resilient against drowning.
Of course. All the excitement. It's wonderful to see. So I want to just add one little caveat. So I'm with the Digital Impact Alliance. We're a not-for-profit based out of Washington, D.C. technically, but actually most of our team is deployed and works in Africa, South Asia, Europe. And we work on a pretty focused scope, which is solving for data scarcity. And our approach to that is really helping to scale digital public infrastructure in places where those foundational layers, the public rails that India has built out in the last few years still don't exist. And that leads us to spend most of our time in sub-Saharan Africa, where there's great enthusiasm, but there is still a work in progress in terms of building out these systems. And so I would say there are a couple of different ways to think about your question of why this digital public infrastructure movement over the last few years has not delivered climate action. And I would say first, it really is this idea that it's still scaling. And second, the really foundational layers that are being put in place first tend to do with personal identity, unique identity, just like Aadhaar here, and payments, either B2B or P2P payments. And so I think that there is a sense that there is a lot of relevance to climate, but the use cases and the applications are not perfectly obvious yet, very clear. So it's a maturity problem, but also kind of the starting point. A big part of the DPI movement was actually accelerated by the pandemic 5 years ago, when there was more urgency and more interest in sending stimulus payments and welfare payments out to people who were being financially disrupted. So I think we're going to get there. But I would say the second real gap that's keeping DPI from being directly applicable to climate action is the fact that geospatial data, in particular hyperlocal geospatial data in urban areas, in countries that are really on the front lines of climate change, just either doesn't exist, right? There's a scarcity problem, or it's just highly, highly fragmented. And so that's the work that we are helping to address right now. And it's, I think there's this idea that mapping has been solved, in part because Google Maps is so good, right? But in truth, there are a lot of places, especially in urban areas, in countries where the demographic shifts, moving from rural areas to urban areas, are changing so quickly that the mapping at a really local level is not able to keep up. And so I think the things that we have to think about are how do you solve for that scarcity in a way that is financially sustainable, right? Because everyone says satellites, or it's already taken care of. And in fact, countries don't have don't have the budget to keep constantly updating through those means. So we look at business model innovations, right? There are some really interesting experiments around not thinking about geospatial data as just private infrastructure, but as a public, even maybe clubbed goods, right? So more of a digital rail that allows public and private innovation on top of it and has a business model for being constantly updated and maintained. And then I would say the other piece is the fragmentation of data, which is already discussed and I think is a big focus of the council's work, which is how do you get this data to work together so that it can be applied to climate action.
Indeed, I think you've highlighted several gaps, a gap in the imagination, a gap in scale, a gap in our hyperlocal mapping and geospatial information. And then, of course, even if we fill those gaps, they might still exist in silos. And some of the things we've been doing at the council, neighborhood scale flood mapping, flood risk mapping for urban centers. And you're exactly right. It's not just about mapping the urban center. Right. It's about mapping the economic activity in different neighborhoods, right. The different economic classes there. Someone living in a shanty town is going to be a lot more vulnerable than someone living in a pakka home, even with the same intensity of a flooding event. So I think layering it with these issues of equity, economic activity, vulnerability, adaptive capacity will be necessary. So that's a great segue to my question for Dr. Ramprasad, because you deal with water supply and sewerage in one of India's most tech-enabled cities. And yet BWSSB has now of late used AI to improve water pumping efficiency. I recall when I started CEW, one of the first things we did was run water dialogues in Bangalore, and SCADA systems, etc., were being considered at that time. So what is missing in the sort of traditional infrastructure and the manual mapping of leaks, etc., that you're trying to plug through AI, and how effective has that been for you?
Thank you for the opportunity. I can see the massive interest in the youngsters to know about how these models can be used in the masses. The case study of the Bangalore Water Supply Board can be a demonstration for what the questions. So traditionally, all the utilities across the India are pumping water simply without knowing what's happening after pumping. So in BWSSB, we have faced a critical challenge during 2024. That's the summer water crisis in Bengaluru, due to which we have been forced to think beyond the conventional model. And we have started thinking in the technological front. Then the AI was the one which was coming up in the way. So we thought we should integrate the AI models into the actual governance model. So in the current case scenario, what BWSSB has done is made an IoT-enabled sensors to assess the pumping capacities and pumps health monitoring, and uses data with AI analytics to predict how these pumps are very efficiency in terms of design and also in terms of field pumping efficiency, and what are the maintenance costs involved and how it can be predictively analyzed. This is the first and foremost important thing, so that we could be able to understand how the water pumping is going to behave, the supply adequacy is there or not in the system, can be very well effectively, can be monitored using the AI-enabled data analytical tools. That is being demonstrated in Bangalore Water Supply Board. More than 78 pumping stations have been fitted with AI-enabled IoT systems, sensors, and we are getting the predictive analytical tools which we are effectively using, both to monitor the efficiency and to improve the efficiency. It's not only a monitoring device, also it's a functional actuating device. Apart from that, we have also used one of the important tools to monitor the groundwater system. You know, in 2024, when the crisis happened, the major problem is due to the groundwater depletion in the system. So which is very difficult to monitor for a conventional methodology, whereas the AI-enabled IoT sensor, which is fitted in the borewell systems as a monitoring borewell devices, more than 3,000 borewells have been fitted across the city to understand the groundwater behavioral patterns. So with this, we have collaborated with Indian Institute of Science, one of the leading institute of the nation, who come forward to develop a AI-enabled dashboard to monitor the groundwater analytics. So with these analytics in 2025, we could be able to forecast how this groundwater will deplete in specific areas. So we could be able to target those deficit area with the enhanced efficiency through the surface water system. That's how I think the AI tools can be very well effectively to counter the challenges of the nature, as well as to prepare for the nature's challenges, to foresee the various challenges coming forward. And in fact, this is a case study which we have presented to the world.
Wonderful, wonderful, and I hope
These are two models that use geospatial data to be able to help build out the agricultural information. And the goal here is, as our colleagues talked about, really spatial resolution is critical. The farmers make decisions at a local level, and so they need really localized information to be able to drive the resiliency that they need. Again, when I was working in Ethiopia,
because it does start to get very, very granular. And I love this saying. I just learned this yesterday, that DPI makes things possible, and AI makes things personal, right? And so when you have those two together, you have this ability to innovate in ways that are contextually relevant.
super. In fact, that leads me to two follow-up questions I want to ask, one to Professor Asaria and one to Ashley. Ashley, if you are seeking that locally relevant data, can you give an example or just what is the process that Google is following to draw on more locally relevant data to plug into your global models? And how do you also ensure that the global models are reflective of those local nuances sufficiently? How do you have trust? How does a user have trust that it does have that relevance? And if I could ask you, Professor Saria, in this context of we all have to kind of put our shoulders to the wheel of filling these different gaps, making it locally relevant. Could you expand a little bit on then why data sovereignty becomes particularly important when it comes to climate resilience in the global south?
मतलब यहाँ पे रिकॉर्ड हो रहा है वहाँ पर जा रहा है वहाँ के लिए जो जाने की स्पीड बहुत स्लो चलती है यूट्यूब में सही नहीं
What is it that external stakeholders need to understand?
है लेकिन बहुत कम नेटवर्क आ रहे हैं यहाँ पे.
Ashley, I turn to you and then Professor Saria, and then again I'll have a hard question for you.
Thanks so much. And I just want to state with that, we use public data, and our models are only able to be developed because we stand on the shoulders of the giants who have really developed this. So I'll take our weather model as an example. Without the ARIFI data set, our WeatherNext 2 model would absolutely not be possible. So I think public data is absolutely critical. And so then it's the question of how do you localize. And so I think, we love making these global models, but global models are only as good as they are able to drive decision, and decisions are local. And so it's then through we have a couple different approaches to how we do that localization. So there's kind of one mode where we can work at kind of giving open access to models, and then having partners do the localization using their proprietary data. We've seen this work with some of our weather models, WeatherNext, for example. We've worked with organizations like Tomorrow Now, working directly with the partners, and they are providing the data, and we're able to really drive up the accuracy. So CEEW is a great example of working in partnership to improve the accuracy of our AMED model, because we really need to make sure that if farmers are making decisions or if organizations are making decisions off these models, they're as reflective as the local situation as possible. But we are a research lab, and so it's an ongoing question. We really need to make sure that we have the most kind of up-to-date data, and if there's data available, we are able to drive those partnerships. So again, it's working with partners and those organizations who have that last mile access.
Professor Saria?
Hello.
So two-part answer. One is related to kind of governance / national security, and one is kind of technical. In my opinion, if we just look at AI as just another model or just another tool, then probably I think there is a lot of confusion, not confusion, but if we think of it just as a model and a tool, then probably the question of sovereignty doesn't arise. But if you do agree, and I believe that it is a new paradigm of computing, like tomorrow's operating system is going to be entirely AI-based computing. I think Windows, Linux, all of them will get reinvented over the next few years. And if you think of it that way, if it were 1980s today, we would never think about renting a computer, right? We bought the computers into the country. The IT revolution started because the government imported the computers and kind of trained the bureaucracy, and of course the private industry also took over. Now, if it were like 20 years back, we would not think about renting a supercomputer from US and Europe. Right, we built our own supercomputers, the Param 10,000 and all these other supercomputers that we built kind of helped us to kind of build our people and infrastructure in that area. And this is the next big platform, next big paradigm. And I don't like to use the word use an AI model, because I think it gives people the false sense of control, that you are using something and you are actually not using it, you are renting it. Right? I'm renting a model from somewhere. Who am I renting it from? If you rent a computer, you'll have a very different relationship with your device, right? So I think it's very important for our country that it has control over the layers, starting off all the way from chips, all the way to the analytics that feeds into the government and private system. So that's one question, and I think the summit itself is kind of surrounding that theme anyway, so I don't need to elaborate on that point. Now the second question is technical, in that suppose you want to improve the models. Now, a lot of the land use data, for example, a lot of the satellite data, they all come under, for various reasons, they are private data sets, right? Space agency, right now ISRO open sources data up to 5 meters, not beyond. So it is not beyond. So it is not possible to get access to this data and feed them to a global model. So weather, land, geospatial, they can be global, but then at the same time, it also has a local context in that India collects a lot of its own data sets. And how do we actually use these data sets if we don't know how to train our models? Our students are not trained, our faculties are not trained, our ecosystem is not trained to using these models. What would we even do with these things? So I think this question arises that how do we utilize? And for that, having the expertise in-house is super important. And of course, we collaborate with everyone, we are open to the world. But as Mahatma Gandhi said, let's have the windows open, let the air flow in, but let us not have the window blown out. The whole house, I don't remember the whole code, but let us not have the entire house blown out. So I think this part is very important, that we build our students, our research base in this area, and that is going to give us the control over the layers so that we can continue to improve these models for climate impacts. And a host of other areas are getting impacted by these models. Climate is a very kind of sustainability, it's a do-good kind of goody-goody feeling word. But this has implications for governance, security, and a lot of other very serious matters. So I think it is very important for us to control this area.
Thank you. That leads me to my last question to Dr. Ramsarath and Ramprasad, and then see if we have time for a couple of questions before we request our Google colleagues to close it out. This issue that Professor Saharia brought up about capacity, he said it in the kind of technical context, but my question to you is in the administrative context. From where I analyze this, I see capacity gaps in analytical capacity, interpretive capacity, and then actionable capacity. So while you can deploy the sensors, you can use the AI to, whether it's the groundwater, the leaks, etc. But how are you? Could you explain a little bit at BWSSB? How are you building the capacity to understand all this and then act on it?
Very good question, because everyone today talking about artificial intelligence and use of it in governance. But in India, we are dealing with 140 crores plus population, and the government is a single entity which is having a predominant role in many of the normal functioning of the human life in India. In this case, when we are using the AI, we have to think about how to use this AI for effectively function. When you say that we have to effectively function, you have to also build a capacity to make it more effective. For that, the human elements is very, very critical. And I can see a lot of young people gathered here, but maybe except me, less people are in the government system who are actually in the dialogue or learning process. But always there is a resistance of change. So when you introduce a computer system in the governance, always there was a resistance, lot of resistance. The same way what Google put, the security of the data, all those issues keep coming whenever you introduce technological models or innovations into the system. But having said that, we can't keep resisting the ideas. We have to keep accepting the ideas and build that, our workforce for the future. In our BWSSB, when we started implementing this AI-enabled system, not only in water pumping station and groundwater pumping station, even for the sewage water treatment purpose. Because many of the sewage treatment plants are running across city, which is spread across 800 square kilometer area. So it's very inhuman for a human being to sit and control the operations of the sewage treatment plant. In that case, what we have done, we have developed a small AI device tool to get the data and analyze and give the input to the field level officials to switch on or switch off, what are the things to be done, the protocol to be followed. So when we started implementing it, we realized that the field level staff and functionaries who are going to use this AI-enabled decision and implement it in the field, it's not automotive mode. They have things are still conventional. So we have to balance between the existing conventional system of control and the innovations of the AI. So unless we bridge this gap of understanding between the elements who are going to implement the AI models and the persons who is giving the decision from the back end. So then we started developing and models and training our own staff in the field to understand how to use this AI-enabled system. And with this capacity building, now we are able to successfully use this AI-enabled sewage treatment plant management system, which is saving us more than 25% of the cost. It stands out to be 1,000 crores rupees per year. So it's not a small thing, but to enable system, we have to enable the enablers. That's the human element. We have to build the capacity, not only in terms of the working force working in the government, also we have to make the consumer. Our consumer is a large citizenry.
Sure.
Unless our citizens are not able to understand what is that, what we are trying to do, then ultimately the effectiveness will come down. Even we are going ahead with the consumer-oriented B2C AI tools like smart metering technology, so that they can effectively use the smart meters to monitor their water efficiency, how well they can prevent the water shortages in their home. To that level we want to micromanage. So for that, so from the head of the department, that information and the capacity should percolate down to the implementing agencies and also to the citizen at the last mile. So this is how we have to move forward, and how the government is taking effort, and this AI summit is one such effort of the government to bring together all the stakeholders of the governance to create the awareness and then action. Sure. Unless you are aware about something, you can't act upon that. And this is government is in the right direction, and government has already enabled the system, and it is in the process. Definitely, we will be able to catch up with the Gen Z's expectation of making AI into the governance.
Thank you. You need to have a digital cadre joining your administrative services now. In fact, we'll have a session, CW will have a session with LinkedIn later this afternoon on the jobs and the skills needed for this future that we are all building together. We maybe have time for two very short questions, for two very short answers before we request Google to close out. So can we have some young person ask a question first? In the red t-shirt at the back. We are recording it, so just please pass the microphone. Very quickly, please.
First of all, thank you for giving me a chance to ask a question. And I have two questions, two short questions to the panel. First question is like we are building in agriculture sector, we are using AI technology, and in USA we know that farmers own large lands and they are capable of hiring these agents, like they are capable of bearing the cost. But considering India, we have small scale farmers, so is like we have a barrier considering the...
Okay, so the cost barrier. I'm afraid I have to stop you at one question. So you were very eager, you can ask your question here.
Thank you.
Good afternoon, everybody. Thanks for the excellent session. I am Jitish from Director Mechanized Farmer Producer Company JNK. My brief question is, can we without, from the panelists, can we without robust digitization of land, farmers and crop data, can AI reach the last mile in agriculture?
Super, thank you. There are two very important questions. One, the affordability for access to these tools for smallholder farmers, and secondly, in the absence of digitized land records, how we actually leverage any of these. Who wants to take, I mean, Ashley, you would be, you know, the spotlight's on you, but anyone else wants to be brave enough to answer this?
Well, on the first question, are the agriculture models are available without cost, the AI models? I think it's, I agree with Google.com. Feel free to fill out a form. It's a allow listing process.
Land digitization, anyone wants to take a stab at this?
Anyway, it's a partially government-oriented system, so I have the responsibility to answer this question. So land digitization is very much in very staggered space. Some of the states like Karnataka, Tamil Nadu are very progressive in implementing the land record digitization for last 2 decades. In fact, Karnataka is the first state to start the digitization of the land records, and it's gone hard. Even the crop data and crop survey, everything is being done through the digital mechanisms and the GIS enabled system. So we are very much prepared. But whereas the other part of the country, like northern states and eastern states, still in the process of digitization of the records. But of course, this is a fundamental data required for any AI system which will take a decision based on the data. So without the fundamental data, it will be really challenging to build a system to work on that. So at least for what we can do, we can make it as a phased manner. At least those states who are not having the data has to come forward to build the data first. And those states who are having the data start implementing this digital driven system using the AI tools, so that can be a model for other states to follow in the days to come.
Thank you. Sorry, you can take your question offline. We can take the question offline. Okay, if you want.
Quickly, I would say there's been...
Sorry, we need to respect everyone's time. You can take it offline.
I mean, just quickly from the DPI world lens, like I think property mapping, updating cadastras is not a technical problem or technological problem. It is purely a political problem. And I do think that there is a way to match AI-driven solutions with places that can still be incredibly beneficial to small farmers, even without that tool.
Professor Saria, you had a thought on this as well, on the digitization. It's been covered. It's a political problem, not a technology problem. I've heard 4 words that matter to me. Trust in an increasingly untrusting world. Partnerships, therefore, that we've got to kind of break down new barriers. Capacity, not just at the data end, but at the administrative end. And ultimately, citizen. I think, Professor Dr. Prasad, what you said, the customer is also ultimately the citizen. And that citizen focus is needed. So thank you for this extremely energizing panel. If I could pass it back to Kunalika, and you can close us out.
Thank you very much, dear panelists, for that insightful conversation. It gives me great pleasure to invite Mr. Raju Sani, Head of Google Research and Applied AI Partnerships, to frame today's context with his keynote remark.
Thank you. I think we're running short on time, so I'm going to try and shorten this part. It was a pleasure to be here. I really enjoyed the panel. I think you closed it out really beautifully there. I love the DPI and AI theme as well that you talked about. I think we all know the weather events are increasing, and Asia obviously is at the forefront of a lot of the vulnerability to the impacts of a warming climate. I'm going to skip to the part where we at Google Research have, and Ashley and our teams are committed to sort of bringing the best of our frontier models and having impact on the ground. I think we talked about this example. I'll just spend a minute on it. Farmers are obviously the backbone of the Indian economy. They are on the front line of the climate volatility. The Indian government has already announced plans through Mission Mawsum to use AI and machine learning to improve scientific understanding and prediction capabilities of India's wealth of weather and climate data. We talked about it a bunch on the panel. Excellent farmer registries to the extent that they exist, and investments in digital platforms have really made it possible to scale forecasts effectively. I want to mention one initiative that we had a small role to play in. During the last summer monsoon, the Indian government leveraged statistics from the Met Department, and they used 2 AI models which best predicted the localized onset of monsoon, one of which was a Google Research model called Neural GCM, which is a model that combines traditional physics with machine learning to provide hyperlocal forecasts. It was a very interesting approach. The ministry was able to warn these farmers about an unusual year in which the monsoon arrived early in Kerala, but its northward progression was actually slow, so it got paused. And so without this forecast, farmers would have actually planted too early. And by disseminating this AI-powered insight, and I'm using the government statistics of 38 million farmers across 13 Indian states, they avoided premature planting. And so these are small pieces of information, but they saved farmers from wasting expensive seeds and fertilizers, protecting some of their income and food security. Google will continue to invest in these digital public goods so that governments can follow examples of the Indian government and show the world how this kind of AI, along with a strong institutional base and a powerful dissemination channel, can be used to improve lives. One quick case study to end with is on flood management. We talked a little bit about floods and the fact that data is scarce, right? Hyperlocal flood data is really scarce. We've been working to scale flood forecasting to millions of people in India. But again, the forecasts are only as powerful as the action that they enable, right? So in Bihar, we partnered with the Yale Economic Growth Center to test the real-world impact of flood alerts. And the results are really powerful, so I just wanted to share that with this group today. Around 35% less spend on illness treatment and 9% less spend on injury treatment if early forecasts are disseminated. For riverine floods is the example that was used for the case study. The economic case is undeniable. For every dollar spent in disseminating these alerts, between $12 and $36 were saved per household when it came to medical expenses. So I want to ground that AI is not just a luxury or a good to have. AI-informed warnings are a cost-effective tool for public health and economic stability. So I just wanted to give these 2 quick examples, and as the panel talked about, technology cannot and should not do any of this alone. And the transition from models to masses really requires the partnership of everyone on this panel, everyone in this room. It's policymakers, it's organizations like the council, it's the partner ecosystem. And so I just wanted to thank everyone for the time today and to commit that we're not here just to build better models, we are here to build a safer and more resilient Bharat. So thank you so much for the talk today.
Thank you, Dr. Ghosh, for moderating this session. I invite Ms. Saroj Bharadwaj from IT team and our officials. Just give a momentum to everybody.
Next session में सिर्फ हम लोग
लंच आ गया आपका ठीक है सर नेक्स्ट में इन्होंने बोला मैडम ने